Okay, everybody, let's do a little recap of what we did in the lesson. So first of all, we did do the first two Mathia lessons, and they're both on recursive formulas. So today we talk specifically about recursive formulas and if it's geometric. So if it's geometric, then we're multiplying. This first term is obviously geometric. My first term is 1, and my r is 2, because I'm multiplying. Okay, so then if I want to complete the table, I would start at 1, and it would just double. Okay, so the first term, it hasn't divided yet, but that is still the first term. So these numbers are a little bit different. Cell division 0 hasn't divided yet, but I still have one cell, and it divides. So these just become division 2, division 3, division 4, division 5. And those are my terms, because that one is really my first term. So then what about a recursive formula? Well, we talked about a recursive formula, okay? And this book's a little interesting because they forgot one thing. You need A1. You need the first term, always, whatever that is. So it says, or I'm sorry, I guess it's G1. So we have g of n, that's to make any term, is equal to g to the n minus 1. We said that that is the previous term, So to make the next term, you take the previous term and you multiply it by your ratio. So here's an example. My first term is 4. So I would go A1 is 4. And then I would say, or G1, oh, forgive me, G1 is 4. And then I would say, okay, g of n is equal to g to the n minus 1. It has to be g to the n minus 1 because that represents the next term times my multiplier, which is, multiplied in this case is 3. Okay? Okay, so then they said, consider, right, recursive form of a sequence using the formula to determine the 11th term. So in order to do the 11th term, I need to know the 10th term. Well, the 10th term is 512, so I had to work it out. There's a 5th, keep going, keep going, keep going. So then I took that term, multiplied it by 2, and I got my answer, okay? And then we're going to talk more about explicit formulas, which makes it a lot easier. So if I did my explicit formula, then I can go straight to the 11th term much easier. Okay, I can go g of n, and the explicit formula is handy because it allows you to go straight to your term. So, for example, here's my formula. They say G1. I like A1. First term is 1. We are doubling. We want the 20th term. It's 20 minus 1, which is 19, and there's the answer. Okay. On these, to get the 11th term, we'd have to put 11 in, 12 minus 1, and we get that answer. Okay. 14th term, we'd have to put in 15 to get that answer. To get the 18th term, we have to put in 19 to get that answer. To get the 22nd term, we'd have to go 23 because it's 23rd term because of the first term. Anyway, as we continue, here's a little story problem. They start with 5 cells into triples, 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 triples. Okay, so we get this, the first few divisions of the cells. A geometric, we've got, they like G, sorry you guys, they go G of n is equal to A1 r to the n minus 1 power. First term is 5, my multiplier is 3, and n minus 1 power. So this allows me to get any term. So if I want the 13th term, I've got to plug in 14 to my formula. I get that answer. If I want the 16 division, I put in 17 because the first one is the no term. And I get this answer, okay? So that's all we have to really do to use our formula. Pros and cons? Well, I don't know. I mean, to be honest with you, I don't think there's many advantages to the recursive formula. I don't really like the recursive formula. All it does, it just describes pattern. It tells you what's going to happen next. I like the explicit formula because it really helps you get the next term. So I like the explicit formula. Recursive formula is G1 equals something, and then Gn equals G to the n minus 1 times your multiplier. And all it does is gives you the next term. I like the explicit formula much better. G of n equals A1 r to the n minus 1 power. And this one will allow me to get to any term I want, the 11th, the 20th, the 50th, whatever. Okay, So that's all I have as a recap, you guys, and I'll see everybody tomorrow.